In this video, we're going to look at the OR gateway. And the OR gateway is your worst nightmare. Let's first look at the split. The OR gateway takes a decision based on data and does that immediately. So a token arrives and based on the conditions that are true, tokens are sent out. It must have conditions on all arcs, or an arc can be indicated as a default. Let's have a look. If A and not B holds, so only A holds, then when a token arrives, then a token is produced on A. If A doesn't hold but B holds, so the second example, if a token arrives, then a token is produced on the arc going out of B. If both A and B holds, and here is the difference between the OR and the XOR, then tokens on both outgoing sequence flows are produced. But what if a token arrives and neither A or B are true? Then we have a problem because we're stuck. So you either need to guarantee that this never happens, or you can indicate one of the arc as a default using this small little diagonal line. This outgoing sequence flow that is the default has no condition on it. So it's the default and nothing else. So if we have that structure, then on the right, if a token arrives and neither A nor B holds, then the token will be produced on the default sequence flow. Then for the join. And I already mentioned your worst nightmare, it's coming. The OR join works as the friendly bus driver semantics. So a friendly bus driver is a bus driver that will go if there is at least one passenger, but will wait indeterminately if another passenger might still come. So a very friendly bus driver. Let's look at an example. Say we have two different parts of the model, two little clouds, and they are merged together in an OR join. If there is a token coming from the top, but no token can come from the bottom, then the OR join will fire. It will consume this one token and produce a token on its outgoing sequence flow. Another example, if there's only a token in the bottom part of the model, then as soon as this token arrives in the OR join, then the OR join will look back in the other branch and see can there a token still come? Well, in this case, from the top, there's no token in this part of the process, so the OR join will fire immediately. Another example, in this case, both of the branches are doing something. So a token might come out of this cloud to the OR join. So let's say that the top one finishes first, and now the OR join, as it is the overly friendly bus driver, looks back in the other sequence flow, in the other part of the model, and sees, hey, there I can still get a token from. So it waits. Only when that token arrives at the OR join, will this OR join then consume both tokens, synchronize them, and exit one token. As another example, notice here, the example is a little bit different. So from the bottom part of the process, this little cloud, there are two exits where a token may go, either to our OR join or to some other part of the model. Here, if we have two tokens, and again the top one finishes first, now the OR join, being an overly friendly bus driver, looks at the bottom sequence flow and checks that part of the model, can a token still come? Well, at this moment, yes, this token can still come. So it waits. The OR join does not fire. If that token that may still come now exits that part of the process and cannot reach the OR join anymore, Now the overly friendly bus driver looks at that branch and then, no token can come anymore. So here the OR join may fire, consume the token from the top and produce one token. Let's look at another example. Here we have a process model showing that we can receive orders and then back order either from London or from Paris. When the order from Paris gets lost, then we notify the customer, and if there are goods to ship, then we ship these goods. So let's look at an example. If we receive an order, then a token is put in the start event. The start event moves this along the sequence flow towards the OR split. The OR split takes a decision based on data, and let's say that for our case we have only products from London, so the OR split forwards the token on the sequence flow towards order from London. That's then executed, and when it's done, the token moves on to before the OR join. Now the OR join looks back at the branch where no token is yet to see if another token can still come. So the OR split looks back, all the way back, and sees, okay, no more token can come, so we can fire. By firing, the OR join takes the token and moves it towards shipped goods. Then the goods are shipped, and once it's done, the token moves on towards the end event, and the order has been shipped. Let's look at another example. In this case, the order contains both products from Paris and from London. Let's first order from Paris, then the token moves on through the OR split, and let's say that the XOR split, and let's say that the products arrived. Now the OR join has a token, so it looks back on the other branch. Can a token still come? Here we have a token that can still come. So the OR join waits. The order is made in London, and then once that finishes, now the OR join has two tokens. There are no more tokens to wait for, so the OR join fires, eats up all the tokens and produces one token. Then the goods are shipped and we are done. Another example. We have another order coming in, and let's say that we again have orders from both London and Paris. We execute London, and the OR join again checks, can another token still come? So it walks backwards, and yes, another token can still come. So in this case, the OR join waits. Then we have, we execute order from Paris, and when that's done, all this time, every millisecond or every smallest time you can imagine, the OR join checks by walking back, can another token still come? And the answer stays yes, because up until this point, another token can still come. Now let's say that in Paris the order got lost. So the token moves through the XOR split down. Now the OR join is still looking back, but suddenly there is no more token that can come to the OR join. So the overly friendly bus driver doesn't see any more passengers and can fire. Well, then the process ends, so the goods are still shipped, the goods from London that we had, and the customer is notified, and then the process can end. We see in this example that the OR join is very powerful. Even though this model is a bit messy, so there are branches escaping and there are merges that we need to do anyway, it is still a good model. But this overly friendly bus driver way of thinking can get you into trouble. Let's look at a model where this does get you into trouble. This is a OR join where it executes depends on another OR join. So we have OR join 1 and 2 and they depend on another. Let's look at how this works. If we have one token arriving into OR join 1, then by the friendly bus driver semantics, it looks back. So it simply walks over here. Oh, this is a merge, so we need to go 2 branches. In this branch, it's fine, no token can come. This branch, if we follow that back, we end up with ourselves. Nah, okay, that's fine. So no other token can come here until OR join 1 fires. So that's okay. OR join 1 can fire. And then the process can end. Now let's look at this example, where we have 2 tokens coming in. Let's look what OR join 1 does. OR join 1 gets a token, so by the overly friendly bus driver semantics, it looks back. Oh, here we end up in a merge, so we need to look at both branches. Okay, so here we have another token. So another token can still come using the orange path to OR join 1. Hence, OR join 1 has to wait. But, and now comes the mean part, this model is completely symmetric. So we can do the same for OR join 2, and if we follow the same reasoning, then if there's a token before OR join 1, then OR join 2 also has to wait, obviously. It's a completely symmetric model. So they are waiting for one another. This is never going to end, so you would say we are in a deadlock. So the model, the tokens cannot progress anymore. Both OR joins are waiting for one another, deadlock. Now, maybe not so nice from a practical perspective. You don't want your model to get stuck, but I mean semantically fine. But by means of the overly friendly bus driver semantics, if 2 tokens are stuck, they cannot reach the OR join after that. So OR join 1 can fire because the token that was waiting for OR join 2 can never come because it is in a deadlock. Similarly, OR join 2 can also fire because it is waiting for a token that never can come because it is in a deadlock before OR join 1. So using this overly friendly bus driver semantics, I can prove that both OR joins should wait in the top, and I can prove that both OR joins should fire. So you see that I've now shown that the friendly bus driver semantics are inconsistent. So what can we do about this? Well, basically nothing. This is an inherent problem of the OR join, and if you connect them in this way, then it is very challenging to define semantics for them such that you don't end up in these situations where you have inconsistencies. Because this is a major problem. You can derive that true equals false, and I don't know if they told you in logic course, if you can prove true equals false, then you made a serious mistake somewhere. So these semantics of the overly friendly bus driver are very dangerous. So, to wrap up the OR join. OR joins can merge paths that are otherwise very difficult to merge, because you end up with situations like deadlocks or remaining tokens. We don't want that. So with OR joins you can merge those paths because OR joins will look back, can a token still come? Very powerful. But avoid using OR joins when you can. If there is another choice, do not use them. They are expensive to compute, they have these issues with semantics, and the whole logic world might collapse if you do. And absolutely never ever ever put 2 OR joins depending on one another, because you might end up in the situation that I showed you with this paradox. And, well, maybe as a critical point, if somebody tries to sell you a tool and claim that tool has full support for OR joins, then run away, because they're lying. It's impossible. Unless very, very specific cases or additional assumptions, but full arbitrary support for OR joins, no way. And that's the OR gateway. I've shown you the split, where args have conditions on them, and then the OR split takes a decision based on these conditions, and a default if you provided that. The OR join is the overly friendly bus driver semantics. Very powerful, can make a lot of models that have problems fine, but might have issues with consistency.